Good morning. Today we're going to be simplifying complex fractions. So first thing we look at when we simplify, we look at, is there anything that we can do in the numerator? Okay, remember this is a group, okay? And so we have 3/4 minus 1/8. So as soon as we see the minus, we should think that we need to get a common denominator so that we can subtract the fractions. So the common denominator here, the number that both 4 and 8 go into evenly, is 8. So the factor that I want to include here is a 2, because 4 times 2 is 8. So if I multiply the denominator by 2, I have to multiply the numerator by 2 as well. Okay? So I call this my special one. 2 divided by 2 is 1. So we're really not changing this number. Okay, we're changing the form of the number. It's going to go from 3/4 to 6/8. Okay, 6/8. So 6/8 minus 1/8 is, let me write that up here so you can see that. 6/8 minus 1/8 equals, we subtract the numerator and the denominator stays the same. So we get 5/8. So we've just simplified the numerator. Now we do the same thing in the denominator. Well, first of all, we notice we have an integer and we have a fraction. So we need to make the integer into a fraction. So we're going to put it over 1. Now, to get a common denominator, a number that both 1 and 12 go into evenly is 12. So what do I need to multiply 1 by? To get 12, I need to multiply by 12. Okay, 12 times 1 is 12, so we get a common denominator. And I need to multiply the numerator by 12 as well. Okay, notice 12 divided by 12 is 1. So I'm not changing the value of this number. It's still going to be the same value. 2 divided by 1 is 2, and 2 times 12 is 24. 24 divided by 12 is also 2, so it's the same number, just a different format. So we're going to get 24/12, so 24/12 plus 1/12. Okay, and 24 plus 1 is 25, and 12, the denominator stays the same. Okay, next, when we're dividing fractions, and this is an important skill for pre-calculus, so please make sure you learn it well. We take the numerator and we write it down. We change division, this is a division symbol, to multiplication. And we multiply by the reciprocal. Okay? So remember, change division to multiplication, and then this would be the reciprocal. Reciprocal. Alright, now we can go ahead and multiply, or we could do some cross-reducing first to make it easier. So looking at these fractions, okay, look crosswise like this, 5 and 25, 5 goes into both evenly. So I'm going to factor out a 5. So I'm going to factor out a 5. So 5 goes into 5 one time, 5 goes into 25 5 times. So what I'm really doing here is I'm simplifying by factoring out a 5 on the top, factoring out a 5 on the bottom, and then those two 5s that I factored out cancel. Okay? Now what can I factor out that they have in common? Well, I could do a 2, but I could get a bigger one too. How about a 4? So if I factor out a 4 here, I'm left with 2. Remember, I factored out a 4. Factor out a 4 here, and I'm left with a 3. Now, the 4's that I factor out, they cancel. Okay, so now I'm left with 1 times 3 over 10. That would be my final answer. Let's take a look at number 2. My lines aren't showing up real well here, but this is 1 over x plus 2. That's 4 over x. Okay, so remember, first thing we want to do is, can we simplify the numerator? No. Nothing we can do in the numerator. Okay, look at the denominator. Can we simplify the denominator? Yes. Okay, we're adding 2 separate fractions here. So remember, we put the integer over 1. Then we have to get a common denominator. Well, when you're dealing with a variable, the best thing to do is just multiply them together. So 1 times x is x. So this needs an x. And if I multiply the denominator by x, I multiply the numerator by x. Okay? So the numerator stays the same. Okay? The denominator, 6 times x, is 6x plus 4 is 6x plus 4. And then the denominator stays the same. Okay? Next, same principle applies. We're dividing 2 fractions. So we write down the numerator. Division changes to multiplication, and then we do the reciprocal on the denominator. Okay, next thing we want to do here is we want to see if we can cancel anything. Also remember, we want to factor anything that we can, and if you'll notice here, we can factor out a 2. So let's factor out a 2. So 2 goes into 6 3 times. 2 goes into 4 2 times. Okay? Didn't help us too much because still there's really nothing left that we can cancel. But it's always worth a try. If we can factor, we should try factoring to see if we can cancel. So we're going to be left with x over, and I'm just going to go ahead and use, I'll go ahead and use my factors. I'm going to start with my number, and the order does not matter when multiplying. X plus 2, 3x plus 2. Okay, let's take a look at number 3. Okay, getting a common denominator. We're adding. So remember, when you're looking at this, you're looking at this has an x and this has an x. Okay, so we're going to need an x. Definitely going to need an x. They both have an x, so we don't need to add an x to either one. This one has a 2, but this one does not. So this one's going to need a 2. Now we've already learned this. These are actually simpler problems, but a little extra steps on the end. So now look, we have a 2x, then we have a 2x. We have a common denominator. So the denominator stays the same. 2 times 1 is 2, plus 3 is 5. Okay? Alright, common denominator. Well, 3 and 4, 12. 3 and 4 both go into 12 evenly. So this is going to need a 4 to make a 12. This one's going to need a 3. 3 times 4 is going to make a 12. So you need a 4 on the top as well. Notice my special 1. Notice these will always make 1 when you divide. Alright, this one has an x and this one has an x. So we're good to go. So my common denominator is going to be 12x. 12x and 12x. Denominator stays the same. Okay, 4 times 1 is 4. Plus 3 times 3 is 9. So 4 plus 9 is 13. Okay. Now we do what we've been doing. We write down the numerator. Division changes to multiplication, and then we write the reciprocal of our denominator. Now we see if we can eliminate. Well, hopefully you see the x's. These are both terms, so we can eliminate. So this x eliminates with this x. And we can factor out a 2 out of these two terms. So let me just show you what this looks like. I can rewrite this as 2 times 1. And I can rewrite this as 2 times 6. So when I say factor out a 2, notice the factors cancel. The same factor cancels. So now I think I'm done simplifying. 5 and 13, nothing. So we have 5 times 6 on the top, 1 times 13 on the bottom. Can't reduce, leave it as an improper fraction. Okay, let's take a look at number four. Last one. Got to move a little bit quicker here. So let's put this line in here. Common denominator here. This is going to be 1 over 1. Okay, well, this has an x minus 1, but this one does not. So we're going to multiply this fraction by x minus 1. And since we're multiplying the denominator by x minus 1, we must multiply the numerator by x minus 1 as well. Now remember, anytime you divide one thing by itself, remember that that gives us 1. Okay? So we have a common denominator on the top, which is x minus 1. I'll be with you in a minute, Sebastian. So we get x minus 1 times 1, which is x minus 1, plus 1. Well, these two right here are going to cancel out. So we're going to end up with x over x minus 1 on the top. Okay, going down here. Okay, putting 1 over 1. We could factor this, but obviously this denominator needs an x squared minus 1. So eventually we will need to factor this. So right now I'm not going to do it. So this side needs an x squared minus 1. So the numerator needs an x squared minus 1 if we put 1 on the denominator. So again, this divided by this is 1. So we have x squared minus 1 times 1 plus 1 over, and then our common denominator is x squared minus 1. Now, again, let's simplify that down. Let's get rid of those 1s on the top because they cancel. Alright, so now we're going to use the rule. So we have the fraction on the top, so x over x minus 1. Change division to multiplication. And then reciprocal of the denominator. And I'm going to go ahead and factor this x squared minus 1 now. That's going to be x plus 1, x minus 1. The difference of two squares over x squared. So at this point, I have students coming in, but there's less than a minute left in this video, so let's quickly cancel some stuff here. X minus 1's cancel. This x cancels with one of those x's, so we're left with x plus 1 over x. Now, if this confused you, please watch the video again, and again, and again if necessary. Okay? And if you have any questions, please come back to my desk and ask. Have a great day.